So in this class, we will discuss the kinematics part of mechanics. So as you know, mechanics can be broadly classified into two categories, that is statics and dynamics. Where statics deals with the bodies at rest and the equations governing the equilibrium, that is static equilibrium. So we have already used these three static equilibrium equations in solving problems. Sigma fx0, sigma fy0, sigma a0, when the bodies are at rest. Dynamics deals with the bodies in motion. That means the velocity, acceleration, distance traveled or displacement, and the force causing the motion, and also the energy involved in motion. Once again, this dynamics is classified into two parts. One is kinematics. Another one is kinetics. Kinematics deals with the displacement, velocity, and acceleration. Displacement, velocity, and acceleration, they are discussed in kinematics part, whereas kinetics includes force and energy also. Force and energy involved in the motion. Now, in this class, we will discuss the basics of kinematics. So, basics of kinematics means you know that there are basically two important quantities called scalar quantity and vector quantity. According to the definition, scalar quantity is a quantity which has only magnitude but no specific direction. No specific direction. Specific direction. Example for this scalar quantity is speed, distance traveled, temperature, mass. So these are all examples for scalar quantity. So it has not only magnitude. For example, if you are speaking about the speed of a vehicle, normally we take 40 kilometers per hour, something like this. This is an example for speed. Distance traveled, of course, 5 kilometers, 6 kilometers, like that. Then temperature, some 10 degrees centigrade, something like that. Mass is expressed in kgs, 100 kg, like that. So these are all the quantities which have only value, numerical value, which is called as the magnitude, but they don't have any specific direction. The second type of quantity which you have learned already is the vector quantity. A vector quantity is one which has both magnitude as well as specific direction. So it has both magnitude as well as specific direction. So it is specified by a particular direction. Example for this is displacement, because when we are talking about displacement, so we speak about the direction, in which direction the displacement has occurred. Then velocity, rate of change of displacement. Then acceleration, rate of change of velocity. Then force, which is according to Newton's second law, mass into acceleration. Then energy. So these are all examples for a vector quantity. Now, in this I can give examples like displacement. Normally we express in meters or kilometers, so 100 meters, something like that. Velocity is usually expressed in meter per second, so 1 meter per second, 2 meter per second, like that. Acceleration is expressed in meter per second square, so that is the rate of change of velocity, which is expressed as 1 meter per second square, something like that. Force is expressed in newtons, so 50 newtons is the force acting in a particular direction, and of course energy is in joules, so from 100 joules, so like that. So these are all the examples for vector quantity which has a specific direction. That is very important. Now, to understand the concepts, so now what I do here is I will take 2 points A and B like this. A and B are the 2 points separated by some distance. Let us take an object, a vehicle or something. It moves from point A to towards point B like this. Then this is called as the distance travelled. So distance travelled is this actual distance travelled. Whereas when you take up the displacement, it is shorter distance, that is direction wise. So I have shown an arrow here. So this is called as the displacement. It's a vector quantity. Speed is not a vector quantity. Distance travelled is not a vector quantity, whereas displacement is a vector quantity. So that means the body has travelled, it has displaced from point A to point B. Maybe it can be some 100 meters, something like that. That is the distance. So there is a difference between distance travelled and displacement. Displacement will have an arrow sign that represents a vector quantity. Next, coming to speed. So if I draw a tangent here at this point, at some point here, like this, so this direction gives the speed. Of course, speed it varies from point to point. Suppose if you take a point here, if you draw a tangent, it will be something like this. If you take a point here, draw a tangent like this. Then that means the speed direction is varying. It is not having a specific direction. It is defined at a point. So that's why speed is taken as a scalar quantity. It has got only magnitude. Now, according to definition, you can write like this: speed can be written as distance travelled divided by time. Distance travelled divided by time is speed. So whatever distance is covered per unit time. So normally speed is expressed in kilometers per hour. Speed of a vehicle or something like that. So the direction of that speed varies. Whereas velocity is nothing but displacement divided by time. So see the difference here. Difference between speed and velocity. So displacement divided by time. So in SI units, the unit is meter per second. So whatever distance an object has covered per unit time, so that is in a particular direction, that is velocity. So this is the difference between speed and velocity. So mathematically, what we can write here is V is equal to S by T. S is the displacement, T is the time. Or if you are speaking about instantaneous velocity, instantaneous at a particular point, that is the meaning of instantaneous velocity. That means as your time tends to 0 or dt tends to 0, you can write small, relatively small time dt tending to 0. This limit dt tending to 0 or delta t tending to 0, ds by dt. So this is called as the instantaneous velocity. But when you are speaking about a problem, we are going to take the average value of the velocity. So that's why normally it is taken as you can write the rate of change of here displacement is called as velocity. Here this is average value. Average V is given by total displacement divided by the time taken. Suppose if a body travels a distance of 100 meters in 2 seconds, then the velocity is 50 meters per second. That is the mean, 100 divided by 2. Now mathematically, I can write velocity like this: V is equal to ds by dt. That means it is the rate of change of displacement. So rate of change of displacement is known as velocity. So in this is the mathematical representation of velocity in calculus. The derivative of displacement with respect to time is called as the velocity. Now next term is acceleration. So when you speak of acceleration, it is nothing but rate of change of velocity. So see the difference here. Rate of change of velocity is acceleration. So that means mathematically you can write this as A is equal to dv by dt. A is equal to dv by dt. So where dv is the change in velocity in a time dt. So this rate of change of velocity mathematically it is written as dv by dt, and that is acceleration. Please note that all these are quantities. All these are vector quantities. I can put an arrow above the notation to represent that it is a vector. Now here, this A can also be written as, even if I don't write arrow above A, it is understood that it is a vector. So d by dt of V is nothing but ds by dt according to definition here. Therefore, d by dt of ds by dt, which is d square s by dt square. So acceleration can also be written as d square by dt square. There is one more form of writing acceleration. So you know that A is equal to dv by dt. This total derivative can be converted to product of two derivatives using chain rule. So that is dv by ds. I introduce ds term into ds by dt. So that is dv by ds into ds by dt is v. So this is another form of writing acceleration. That means acceleration can be written in three different ways. One is dv by dt, second one is d square s by dt square, third one is v into dv by ds. So this is how acceleration can be expressed. So this is about displacement, distance traveled, speed, velocity, acceleration. And in acceleration, if the value is negative, that means if the velocity increases with time, then it is positive acceleration. If velocity decreases with time, then it is negative acceleration. That means, or it is also called as retardation or deceleration. So I will write here. Suppose if I take two points A and B. At the point A, the body is moving with a velocity u. At the point B, it reaches a velocity v, let us say. So the distance travelled is s here, and the time taken is t to travel from A to B. Then here u is called as the initial velocity. U is called as the initial velocity. V is called as the final velocity. Final velocity. So t is the time taken from A to B, to travel from A to B. Then S is the distance traveled or the displacement. I can write as displacement is a better word. So these are the things. So because if I write an arrow here, that represents displacement. Now these are the four important parameters. Using these four important parameters, we can always derive the fundamental equations of linear motion. Here this is a linear motion problem because the motion is along a straight line. Now I will take from these four, we can always derive three important fundamental equations of linear motion. So let us see how we can derive it. It's a very simple derivation. So three important fundamental equations of linear motion can be derived, which are used to solve problems on linear motion. So equations of linear motion in terms of these four. The first equation is v is equal to u plus at. Second equation, s is equal to ut plus half at square, and third one, v square is equal to u square plus 2as. So these are the three important equations. In the examination, they can ask the question, derive the three fundamental equations of linear motion. Here, please note that A is the acceleration. A is the acceleration. Now let us take v is greater than. Let v is greater than u. That means the velocity is increasing from point A to point B. So v is greater than u. So in that case, acceleration will become rate of change of velocity, that is change in velocity divided by time. According to definition, I am talking about the average value. So change in velocity divided by time is the acceleration. Change in velocity is v minus u divided by time is t. So in time t, the velocity has increased from u to v. So this is the mathematical equation. If you cross multiply, v minus v is equal to a into t, or v is equal to u plus at. So this is first equation, very simple derivation. First equation we have derived. For the second equation, s is equal to ut plus half at square. So for that, so what we will do here is, I will take the definition of, once again, acceleration. I will take the definition of acceleration. So a is equal to v minus u by t. Now substituting for, this is second derivation, this is first derivation. Substituting for v as u plus ad. So let us see what happens. So here, so a is equal to u plus ad. Once again, here to derive the second derivation, what I will do here is, I will take the definition like this. So you know a is equal to v minus u by t as per the definition. Now what I will do here is, I will take the definition of s. S is the displacement of the body from point A to point B. So s is equal to, I will take the average velocity multiplied by time, use the, because we know that v is equal to s by t. Velocity is total distance traveled divided by time. Here of course, since I am taking average value, average velocity, I will take average velocity v plus u plus v by 2 into time is t. Now what I will do here is, substituting for v as u plus at. Now and then simplifying that, we are going to get the second equation. So to get the second equation, we have to eliminate v. So substituting, I write here, substituting for v as u plus at, which we have got from the first equation. So what happens, s is equal to u plus at by 2 into t. Like this we get. So this is 2u plus at by 2 into t. So these 2 will get cancelled. So finally we get with s is equal to u into t plus half at square. You can see that this is a very simple derivation. Second equation we got. The second equation gives the relationship between u, t, a and s. First equation gives the relationship between u, v and t. Now we will go to the third equation. To derive the third equation, so that is v square is equal to u square plus 2as. So now what I will do here is, I will just once again take the definition of s. So we know that s is equal to average velocity multiplied by time. So average velocity is once again u plus v by 2 into time. Here this time, what I can write here is, you can use this equation. So we know that v is equal to u plus at. So therefore t is equal to v minus u divided by a. So please note that I have written like this. So t can be written as v minus u divided by a. So now the numerator is a plus b to a minus b. That means v square minus u square is got divided by 2a. So s is equal to this one. Or if you cross multiply, v square minus u square is equal to 2as, or v square is equal to u square plus 2as. This is third fundamental equation of linear motion. So these three equations we have to remember for doing problems on kinematics, because kinematics deals with velocity, acceleration, displacement. So we have to use these three equations now. Only thing here, I am taking the acceleration. Please note that in the above equations, So these are the three equations. This is equation 1, equation 2 and equation 3. So 1, 2, 3, these three equations we are taking acceleration positive. Acceleration positive means v is greater than u. Suppose if acceleration is negative, that means if u is greater than v, that means velocity reduces. Velocity reduces from A to B, then it is called as retardation. Negative acceleration is called as retardation, or it is also called as deceleration. Acceleration negative means initial velocity is greater than final velocity, or final velocity is less than initial velocity. In that case, the equations, if it is the case of retardation, A is replaced by minus A, so that means V is equal to U minus AT, S is equal to UT minus half AT square, and V square is equal to U square minus 2AS. So this is what we have to use in the case of retardation. So A is replaced by minus A. A is replaced by minus A in the above equations. Then we get the equations for retardation. So retardation means when the brakes are applied, and the body is come to body is allowed to come to rest, then with some velocity the body will be moving. So like this, with some velocity, and here velocity is 0, then this is the case of retardation. So if your final velocity becomes 0, it is the case of retardation. So during this process, we have to apply these equations. So naturally, normally in a problem of linear motion, initially the body starts from rest and it attains some velocity. Later on, it moves with a constant velocity. Then brakes are applied and it comes to rest with retardation. So therefore, it is a case of there will be three stages in the motion problem, that is body's motion problem. That is, first one is acceleration, then constant velocity region, that is where acceleration is 0, and the third part is retardation, that is acceleration is negative. So we have to solve problems of that kind.